The goal of this video is for me not to write off the out of the range of this little camera. That's my goal anyway. Your goal is to learn about the second method of alpha alkylation, which is acetoacetic ester synthesis. So this compound that you see here is acetoacetic ester, and look at it. Look, does this look familiar to you? You've got an ethyl ester group on an alpha carbon, and on the other side you also have a carbonyl. So this is another one of these what they call 1,3 dicarbonyl compounds. 1, 2, 3. So there's two carbonyls with alpha hydrogens in between them. On this side, instead of having another ethyl ester, we have a methyl group. So this compound is referred to as acetoacetic ester. We have alpha hydrogens here that are next to one carbonyl, and they have a pKa. Trying to get the focus here to wake up. Okay, they have a pKa of 19, like acetone, and then the hydrogens in the middle between the two carbonyls are much more acidic, 10 to the 8th more acidic, pKa of 11. So if we add a base like sodium methoxide, again, that will deprotonate here. Then we can add an alkyl group here, and we can deprotonate twice and add another alkyl group on there and get a final product. Then we can add H3O to convert our ester. Now we only have one ester into a carboxylic acid, and we can heat it to get a decarboxylation reaction. And if you think about this, you get rid of that and you have added a 3-carbon chain onto an alkyl. So we're adding actually a methyl ketone on the end of some alkyl group from alkyl halide. So the mechanism is exactly the same as the mechanism for the previous one, and so we're not going to go through that, but let's think about what we can do here. So we add 1 mole of sodium ethoxide, and that deprotonates here. Then we can add whatever alkyl group we want as long as it's methyl or it is primary. So we will add a 1, 2, 3, 5-carbon chain with chlorine on the end of it, and then we can deprotonate again and add another alkyl group. How about an ethyl group this time? Again, doesn't matter if we have a chlorine, bromine, or iodine on as a leaving group, that works. So if we draw the product of these 4 steps anyway, then we will end up with our acetoacetic ester, where both of these hydrogens have been replaced by alkyl groups. The second one was an ethyl group, 2 carbons, and the first one was a pentyl group, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And then we're going to add H3O and heat, and we're going to turn this into a carboxylic acid, and then we're going to heat it and blow it off as CO2. And our final product is going to be this methyl ketone. Again, here are the 3 carbons that have come from our original acetoacetic ester. And then onto this alpha carbon we have added a 1, 2, 3, 4, 5 carbon chain, and we have added also a 1, 2 carbon chain. So this is a way to make methyl ketones. Let's have you make one. Okay, so whoops, oh, I failed already. Not too badly though. I caught myself. So this is your target molecule. You're going to make that from acetoacetic ester. Go ahead and stop, pause the video, and draw that out. And when you got it drawn out, then come back and check your work. Okay, welcome back. Here is your target molecule. You know that this came from acetoacetic ester, and then these other two pieces were your alkyl groups that were attached. So if we're doing this synthesis, we are starting out with acetoacetic ester, and we are adding first sodium ethoxide, second one of these alkyl groups. Let's pick this one, 1, 2, 3 carbon chain, 1, 2, 3, with a leaving group on there. Add another mole of sodium ethoxide, and add our second alkyl chain, which is 1, 2, 3, 3 carbon chain. It's a 1, 2, 3, 4 carbons, so it's an iso butyl group. And then the last step is, of course, H3O and heat. So this is the second method of alpha alkylation. And this method is always going to give you a methyl ketone as a product. And so anytime you want to make a methyl ketone, if there's branching or there's no branching on the alpha position, as long as there's no branching on the beta positions, right? So no branches here. As long as there's no branches on the beta position, then you can use a primary alkyl halide and primary alkyl halide there and get the desired product. Malonic ester synthesis was a way to make carboxylic acids by extending the chain by 2 carbons. Acetoacetic ester synthesis is a way of making methyl ketones by extending the chain by 3 carbons, the 3 carbons that come from the acetoacetic ester. In the last video, we will talk about direct alkylation, and there's some specific instances when we can carry out that method.